Oh, good morning, students. So the topic today that we are going to discuss is the solvation energy and the solubility of ionic compounds. So when we dissolve a tablespoon of sodium chloride in water, it dissolves instantly. It doesn't take so much time. But when you dissolve a tablespoon of sugar, it takes some time. That means ionic compounds are generally soluble very fast. Okay. So the solubility of ionic compound in different solvent depends upon the lattice energy of the solid. So ionic compounds are generally soluble in polar solvents like water, ethanol or tetrahydrofuran, but are insoluble in non-polar solvents like carbon, tetrachlorides, benzenes or hexanes like solvents. Now, in order to dissolve an ionic solid in a polar solvent, the lattice energy that holds the ions together in the crystal must be broken down. That means the if you would like to dissolve an ionic compound, the solvation energy must be overcome, means the solvation energy amount must be greater than the lattice energy, or the solvation energy must overcome the amount of lattice energy. Okay, the energy required to break down the lattice energy comes from the strong interaction between the cations and anions with the oppositely charged. The energy required to break down the lattice energy comes from the strong interaction between the cations and anions with the opposite pole of the polar solvent molecule. That means when you dissolve an ionic compound, the dipole solvents generally have two poles. The opposite poles of the corresponding solvents interact with the either cations or anions, and they breaks apart the crystals and solvate the ions, and finally the solid dissolves. Because of the strong interaction between the cations and anions with the solvent molecules result in the solvation of ions, that is the ions are surrounded by right now a huge number of solvent molecules, and these conditions are called solvated ions. As for example, I have demonstrated here two very representative picture where the sodium ion is a cation is surrounded by the negative end of the dipole, that is oxygen atoms, by a finite number, and similarly the anion, that is chloride ion, is surrounded by the positive end of the dipole, that is the hydrogen atom, in like this fashion. Okay, so solvation is a bond making process, and we already known that when a bond is formed, a huge amount of energy is released, and this energy is called the solvation energy. And if you use water as a solvent, then this energy is called the hydration energy. Okay, and you have to again keep in mind that the amount of energy released during the solvation of ions depends upon the dielectric constant of the solvent. The dielectric constant of water is 80 at 25 degrees centigrade. It is the experimentally measurable quantity. It means that when an ionic compound dissolves in water, the attractive force between the ions are reduces to 1/80th fraction of the force between the ions separated by the same distance in vacuum. That means when the crystal is formed from its gaseous phase, whatever force that holds the two ions in the crystal, when they dissolve, when you put this ionic crystal in the water, the force is reduces to 1/80th fraction in comparison to the vacuum. The solvent which causes greater solvation of ions releases the higher amount of solvation energy and are generally known as good solvents. And we know water is the solvent with a high dielectric constant. That means within water the force, or you can say lattice energy, reduces to 1/80th fraction of the lattice energy in vacuum. That's why water is a very good solvent and dissolves lots of ionic compound.